Number 5 and 6 on the review are parallel and perpendicular lines. What you need to do with these is compare slopes. You need to find the slopes. You might have to do a little bit of fraction work. So I'm going to find the slope for AB here. Remember, slope is rise over run. So I'm going to go up 2 here and over 1, 2, 3, 4. So for AB, the slope was 2 over 4. For CD, I'm going to go up 1 over 2. If you're not sure if those are the same, you can absolutely use Desmos to compare them. 2 divided by 4 is 0.5. So is 1 divided by 2. So if you're not comfortable with reducing fractions, you can absolutely get the decimal approximations, or the exact decimal, which that is. And then you can say, okay, if they have the same slope, they're parallel. Remember, for perpendicular lines, our slopes are opposite reciprocals, or we flip the fraction, switch the sign. So we'll compare those here. Again, AB, I'm going to do rise over run. 1, 2, 3, 1, 2. So 3 over 2, up 3, right 2. For CB, we're going to start here at C. I'm going down 1, right 2. So down is going to be negative. So those are opposite signs, but they are not, the fractions are not flipped. So we would say neither here. If we had a fraction of 3 over 2, to have a perpendicular slope, it would be negative 2 over 3. Those would be perpendicular. Just to review what that would look like before we go on to the next problem. All right, next. Write the equation of the line that is parallel and passes through point P. Okay, we need slope, point slope form for this. So when we're using point slope, remember our slope goes in that middle blank. An x coordinate goes next to our x, and a y coordinate goes next to our y. So I like to start out by identifying the slope that I'm going to use. For if we want parallel slope, or parallel line, we're going to use the same slope. So here is our slope. That's what we're going with. Here's our x, and here's our y. That's going to go on our blanks next to x and y. So I'm going to write that fill in the blank. The first thing I always write in is that slope. I'm using the same slope because I want a parallel line. I'm going to put x next to my x, y next to my y. Now, if you're just asked to write an equation of a line, that's a lovely equation of a line. If you're asked for slope-intercept form, then we need y all by itself. I'm going to go ahead and do those 2 steps for you. We would distribute our 4, so that would give us 4x minus 8, and then add over 5. Remember that when you're using a video to review, at any time you can fast forward, pause, rewind. That's the kind of beauty of the video that doesn't happen. You can't do those things in class. You can also check this. So I'm pretty sure about the slope, but maybe you're not sure that you're going to the correct point. You can put into Desmos y equals 4x minus 3. And you can look at that table and make sure that 2, 5 is in your table, and it is right there. So you have the slope of 4, because that's the number in front of your x. It goes to the 0.25. That's a great way to check your work. All right, I'm going to do the same thing here with the second problem. I want the same slope since I'm doing a parallel line, so I'm going to put -1/3 right in here. I'm going to put my x next to my x. I'm going to put my y next to my y. Now you can write this as minus and negative and clean up your signs, make it a plus. Or you can go directly to +2 when you know you're switching the signs. All right, I'm going to solve for y again, just in case you were to need slope-intercept form. -1/3 times x is -1/3 x. -1/3 times -3. Remember, fractions at Desmos are super easy. Negative times a negative is positive. 1/3 times 3 is 1. And then it subtract over that too. All right. Now we're going to do a couple perpendicular lines. So if we're working with perpendicular, what we need to do with our slope is flip the fraction and switch the sign. So I'm going to take this fraction, my new slope that I'm going to use, I'm going to flip that 1/2 to 2/1, and I'm going to make it negative. That's all we use that equation for. Now you can't ignore that equation. You don't need it anymore. Don't get distracted by that 4 or that y. So I'm going to put -2 in for my slope. I'm going to put my x next to my x. I'm going to put my y next to my y. And then I'm going to roll. I'm going to go ahead and solve for y again. Y minus 2 is just going to hang out while I distribute this -2. Be careful with your signs here. -2 times -4 is +8. Again, you can double check this in Desmos. You would put this in, just like we put in that last problem, y equals -2x plus 10. And we want to make sure this goes to the point 4, 2. So what I need to do is go down here and put in 4, hopefully 2 is the point that I get out. You can put in your original line and look at it and make sure it looks perpendicular, but that's not 100% necessary. Okay, same work on number 10. Here is the slope of my original line. The slope of my new line is going to have a flipped fraction, so 2/3 is going to change into 3/2, and it was negative. My new slope is going to be positive. Flip the fraction, switch the sign. And now we're done with that equation. Don't let it distract you anymore. (3/2) goes in my middle blank. X goes by x. I'm going to go ahead and make it a +4. Y goes by y. Three halves times x is 3/2 x. 3/2 times 4. 3 times 4 is 12. Divided by 2 is 6. You can absolutely do that in Desmos as well. No big thing, you don't have to do that fraction work yet. And our last step is to add over our 2. Again, you can double check that and make sure it goes to the point that you intended it to go through. All right, the next video will have some Pythagorean theorem problems in it. So go ahead and watch that if you need.